In this video, we are going to apply the formulae of geometric sequences to solve a daily life problem. It's given that the amount of electricity generated by burning coal in a city in the first year is 5 times 10 to the power of 7 units. In subsequent years, the amount of electricity generated each year is 10% less than that in the previous year. Part A, we need to find the total amount of electricity generated by burning coal in the first 10 years. Let Tn units be the amount of electricity generated by burning coal in the nth year. The amount of electricity generated in the first year is 5 times 10 to the power of 7 units. From the second year onwards, the amount of electricity generated is 10% less than that in the previous year, which is a fixed ratio between any two consecutive years. Therefore, T1, T2, T3, so on and so forth, form a geometric sequence, where the first term is 5 times 10 to the power of 7, and the common ratio is 1 minus 10%, that is 0.9. So the required total amount of electricity is the sum of T1, T2, T3 till T10. With the first term and common ratio known, we can apply the summation formula. The result is 3.26 times 10 to the power of 8. Part B, we need to find in which year the amount of electricity generated by burning coal will first drop below 1 times 10 to the power of 7 units. Suppose that in the kth year, the amount of electricity generated by burning coal drops below 1 times 10 to the power of 7 units. We can set up an inequality like this. All we need to do is to solve for k. Simplifying the inequality, we have 0.9 to the power of k minus 1 is less than 0.2. Take the logarithm of both sides, then bring down the index k minus 1. We've got k minus 1 times log of 0.9 is less than log of 0.2. When dividing both sides by log of 0.9, do remember to reverse the inequality sign as log of 0.9 is less than 0. Finally, we've got k is greater than 16.27. Therefore, the smallest integral value of k is 17. That is, the amount of electricity generated by burning coal will first drop below 1 times 10 to the power of 7 units in the 17th year. Part C, we need to determine whether the total amount of electricity generated by burning coal since the start of the plant will not exceed 6 times 10 to the power of 8 units. Quite obviously, we need to consider the sum to infinity. What we can do is to compare the total amount of electricity generated in any number of years with the sum to infinity. The electricity generated in each year should be a positive value. We can confirm this from its general term. And the total amount of electricity generated in any number of years should be less than the sum to infinity. With this relation, we can now find the sum to infinity to see what conclusion we can come to. Putting the first term and the common ratio into the formula of the sum to infinity, the result is 5 times 10 to the power of 8 units, which is less than 6 times 10 to the power of 8 units. Therefore, the total amount of electricity generated by burning coal since the start of the plant will not exceed 6 times 10 to the power of 8 units. The claim is agreed. That's it.